The first part of 6.3 is kind of the different ways of proving that a quadrilateral is a parallelogram. Okay, so, sorry, that was not. Okay, the different way of proving quadrilaterals are parallelograms. So, definition was that two pairs of opposite sides are parallel. Okay. The second one was two pairs of opposite sides are congruent. One angle supplementary to both consecutive angles. Two pairs of opposite congruent angles. And then diagonals bisect each other, which also means they share a midpoint. Now again, remember that that means there's two of them that have to do with sides. Two pairs of opposite sides parallel, two pairs of opposite sides congruent. There's two of them that have to do with angles. One angle supplementary to both consecutive angles, or two pairs of opposite congruent angles. And then one with diagonals, which is just that they bisect each other, meaning they share a midpoint. Oh, sorry, I forgot this one. And then the one that mixes parallel and congruent. But remember, it needs to be the same pair of sides, parallel and congruent. So it's got to look like the same pair of sides, parallel and congruent. Okay, what we're going to be doing today is the coordinate geometry part of this. So first of all, let's write down the formulas just to make sure we've got those fresh in our minds here. The formulas that you will be needing will be slope, which remember is y2 minus y1 over x2 minus x1. What do you think we would be using slope for? To show parallel, or to show congruent, or to show a midpoint?
Probably parallel.
Probably parallel, right? So if you're trying to show that segments are parallel, we're going to be using slope. Now, slope would also tell you perpendicular, but we don't need that right now for what we're doing. Okay, distance formula. Remember, distance is the one that has the big square root in it. Square root of x2 minus x1 squared plus y2 minus y1 quantity squared. Now, distance you're using to find length. That means if you want to show that segments are congruent, we're going to use distance. Okay, and then hopefully it's obvious that if you're trying to find a midpoint, you'd be using the midpoint formula. And remember, the midpoint formula is average the x's, so x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, so those are the formulas that you need for what we're doing today. Okay, so everything here relies on either slopes to show parallel, distance to show congruent, or midpoint to show that two segments have the same midpoint. So we're going to do the same problem 4 different ways. Okay, these are all the same problem. So it says show that A, B, C, D are the vertices of a parallelogram. That means given those points, prove that that's a parallelogram. Now, when you're looking at that, you're probably like, yeah, it looks like a parallelogram. But we are proving this, which means we're going to show with numbers, with calculations, that it's a parallelogram. If I said you can do this however you want, then you get to choose whichever way you think is easiest. There's all those different options, right? So you can do parallel sides, or you can do diagonal sides to each other. There's all those different options. But we're going to talk about how to do each different part of that. Okay, so the first one says show that opposite sides have the same slope. That means we're using the formula that says if a quad has two pairs of opposite parallel sides, then it's a parallelogram. So, formula. To show they're parallel, we're using slope formula, right? So we're going to show that, it says show that. We know it's a parallelogram. We're going to show that the opposite sides are parallel. And we're going to calculate it because you won't always be given a picture, okay? So we want to show that AB is parallel to what side? AB is
CD.
CD. So we're going to be doing the slopes for A, B, and C, D. So let's go ahead and do that. Change in Y. I'm going to highlight these, or well, I'll just circle them here. Circle those points to make them a little easier to see. Okay, so AB is going to be 5 minus 3 and 3 minus 1. 5 minus 3 over 3 minus 1. So that's 2 over 2, slope of 1. Now, you know, it should make sense with our picture here. Again, you won't always be given a nice picture like that, but you could tell that slope should be up 1 over 1, up 1 over 1. So positive 1 seems right. Okay, and then CD, change in Y is 1 plus 1 over 9 minus 7. So 2 over 2 is also 1.
1.
1, right. So that's going to tell you that those are parallel. Now, is that enough to tell us that that's a parallelogram? So if you show that that's parallel and that's parallel, is that sufficient to tell you it's a parallelogram?
No.
No. What other kind of shape has one pair of parallel sides?
Trapezoid.
Yeah.
Right. So if you only show one pair of parallel, you know that it's potentially a parallelogram, but it could maybe also be a trapezoid. So we want to make sure we do both pairs of opposite sides. Our other pair would be BC and AD. Okay, so BC is going to be 5 minus 1 and 3 minus 9. So 4 over negative 6. Now make sure you're simplifying your slopes, your fractions. I was telling my honors classes, they were really bad about simplifying fractions. And so they were leaving weird things like negative 4 over 6. What should that be simplified?
Negative 2 over 3.
2/3. Okay. And then we can also double check it here. So down to right 3, that seems to work. Okay, so it's negative slope, it's falling, and down to right 3 looks good. Okay, and then for AD, we've got 3 plus 1 and 1 minus 7. So 4 over negative 6 is also negative 2/3. And again, that's going to mean that those are parallel because they have the same slope. Since segment AB and segment CD have the same slope, they are parallel. Similarly, segment BC is parallel to segment AD because, and I'm going to actually say here, both pairs of opposite sides are parallel, then ABCD is a parallelogram. Okay, so if you're showing that a quad has two pairs of opposite parallel sides, then you have to do slope 4 times, right? We're doing slope 4 times here. Let me write that. Because again, if you stop after you just show one pair of parallel sides, then it might just be a trapezoid. Okay, you've got to make sure you do 4 slopes on the 4 sides. All right, that's method 1. That's option number 1, or that might be the way I tell you to do this on the next quiz. Okay, second option, show that opposite sides have the same length. Show the opposite sides have the same length. Okay, Kara, what formula will you use to show the opposite sides have the same length?
Could you use the distance formula?
How many times will you have to do that?
Wouldn't it still be 4?
There'll be 4. Again, the formula, or sorry, the theorem that we're using is if a quad has 2 pairs of opposite sides congruent, and it's a okay, so we're going to do distance on all the sides. I'm going to go ahead and scroll up here and kind of do them like one at a time and then move it down because it's going to be too hard to be jumping back and forth and I don't want to have to copy that down there. Okay, so for segment AB, Derbla, tell me what numbers should go in for segment AB's length.
You should do 3 minus 1 plus
Squared plus
squared plus wait, I think
you're right so far.
I think okay. No, I think I was supposed to do 3 3 minus 3. No, 1 minus.
Okay, so
1 minus 3.
subtract
Okay, wait.
is, but the order actually doesn't matter. On this one, because you're squaring, it doesn't matter which point you start with. Just make sure that you group x's together and then group.
Okay.
So if you do 3 minus 1, you get 2. If you do 1 minus 3, you get -2. Both of those, when you square them, you get the same answer. So the order doesn't actually matter as long as you put x's together and then put those together.
Okay. So then 5 minus 3. Squared.
Okay, so we've got the square root of 2 squared plus 2 squared. And make sure we follow order of operations here. It'll be 4 plus 4, which is square root of 8. Kendall, do you remember how to break down that radical?
Yeah, so wouldn't it be 4 and then 2 and then 2 and 2 on the other side?
Okay, so when you write it as a radical, it's what?
2, like radical 2. Yeah.
2, right. Okay, so I just want to make sure you guys know that I did put a submission place to be putting these notes. So please be writing down all the calculations, not just bits and pieces. Okay. Let's do the same thing for, since we're trying to show opposite sides or congruent, I'm going to go ahead and do the opposite sides. Diamond, can you tell me for segment CD what the calculations should be?
It should be 9 minus 7 squared.
And then
1 minus -1 squared. So it'll be 1 plus 1.
1 minus 1 becomes, sorry, 1 minus -1 becomes 1 plus 1, right? So we've again got 2 squared and 2 squared. So of course it should come out to be the same thing because we have the same numbers. So, sorry. So we got square root of 4 plus 4, square root of 8, 2 root 2. Okay, now again, we know this is a parallelogram, so they better come out to be the same. If they don't, then something's wrong. Okay, so we just showed that A, B, and C, D are congruent. Okay, I should move that up so I can put that in there a little better. Okay, so that's A, B, and C, D are congruent. Okay, B, C, Sam.
Is it 3 minus 9 squared?
3 minus 9, and then what?
And then 5 minus 1 squared.
Yep. Okay, so we have the square root of -6 quantity squared and 4 squared. So 36 and 16. Let's see there. So that's square root of 52. Sadie, can you simplify that for me?
Give me a second, please.
$52 is even, right? Two and what?
26.
Okay. And then 26 is 2 and what?
13.
Okay. And then those are all primes. So this turns into what?
2 square root 13.
Right. So again, remember that the pairs, the numbers that are the same pair up and go outside as 1, because you're really doing like the square root of 4 times the square root of 13. If you look at that and notice that 4 is a perfect square that divides into 52, you can do that directly. A lot of you probably would not really have like noticed that because you probably don't know multiples of 13 that well. But if you did notice that, you could just go directly to square root of 4, square root of 13. Okay, so there's BC. I'm kind of running out of room here. Move this guy down here. All right, and then our last side, AD. Ryan, tell me what numbers to put in there.
Okay, 1 second. AD. So it'd be 7 minus 1 and then squared and then -1 plus 3.
Oh, careful.
Or no, sorry, 3 plus 1.
Sure. -1 minus 3 or else 3 plus 1. Yeah, and again, the order doesn't matter. You don't have to be consistent like you do with slope because we're going to square it and it'll end up taking care of that anyway. Okay, so 6 squared and 4 squared. Got the same numbers, 36 and 16. Square root of 52. 2 root 13. Same answer. Again, should not be surprising because we knew that it was a parallelogram. Sometimes we'll say, you know, decide if it is. So sometimes it doesn't tell you that it is. Sometimes it'll say like, you know, determine whether or not this is a parallelogram. Right, but we've got both of these being 2 root 13, and that means that they are also congruent. So we have proven that because both pairs of opposite sides are congruent, that makes that quadrilateral parallelogram. So A, B, and C, D are congruent. B, C, and AD are congruent. Because both pairs of opposite sides are congruent, it's a parallelogram. Okay, that's method number 2. Now, again, you would not be doing all of these normally with one problem. I'm just using the same problem repeatedly because there's no reason to start over with different numbers. But you would choose one method 1, 2, 3, or 4. Okay, so like this would be a complete solution. That right there, you'd be done. Okay, or if you do just this, that's a complete solution. Now, another option, remember that you can show that one pair of sides is congruent and parallel. So you could mix slopes and distances. So whereas up here, we had to do slope 4 times, and here we had to do distance 4 times. For this method, if you wanted to show one pair of sides as congruent and parallel, how many calculations would you have to do? How many slopes and how many distances?
You can do two distances,
2 distances and
2 slopes.
2 slopes. How would you decide which sides to do it on?
Opposite sides.
Slopes 2 times and distance 2 times, and make sure it's a pair of opposite sides in the same pair. Okay, you want to make sure you pick one pair. I'll say pick same pair of opposite sides. So that means that you would do, for example, let's see, A, B, and C, D. You would do like slope on A, B, and C, D, and distance on A, B, and C, D, and then you'd be done. Okay, or you could do slope on BC and AD and distance on BC and AD. Okay, so then you would be done. So you don't have to do 4 slopes and 4 distances. You just pick a pair of opposite sides and you do slope twice, you do distance twice. Okay, normally I'm going to tell you on a quiz what method to use, most likely. Okay, A, B, and C, D are parallel and congruent. That would make it a parallelogram. So usually I'm going to tell you which way I want you to do it. But if you get to choose, you might have a preference of one thing over or something else. Okay, and then the last way, because with the different ways of proving parallelograms, we don't really have a formula that helps us much with showing angles congruent or supplementary. So we're really kind of focusing on sides being parallel or congruent, and then the one that mixes parallel and congruent. And then the last one that we're using formulas for is to show the diagonals bisect each other. Okay, we don't really have a way to show angles congruent using formulas. Okay, so show the diagonals bisect each other. And again, that means they have the same, what? What goes
Midpoint.
Midpoint.
So that's the formula we're using, right? We're showing that the diagonals have the same midpoint. So we want to make sure we're using diagonals here. Now, in case I haven't mentioned this, I don't remember if I've said this to you guys yet. When you have, try that one more time. It doesn't really like the way I draw these sometimes, if it's too curvy. Okay, there we go. If you're drawing a quadrilateral, I think we talked about this, just I didn't emphasize it maybe the way I should. If you don't have a graph to look at, if you just know you have a quadrilateral, how do you name, if it's A, B, C, D, let's say I put A here and I put B here. Where does C go?
Bottom left.
Bottom.
Right, it's got to go in order. So even if you don't have a picture to look at, you need to make sure you understand which are sides and which are diagonals. Because if you think you're trying to prove these two sides parallel and you have C and D switched up, well, maybe not so much that one, diagonals, for example, if you draw it incorrectly, like if you accidentally put D here and, sorry, C here and D here, then when you think you're looking at a side AD, you really are not looking at, sorry, a diagonal, you're really looking at a side. Okay, so it's super important that you pay attention to the order in terms of when you're looking for diagonals. Okay, so the diagonals in this one are BD and AC. So you want to make sure you grab diagonals here. Segment BD and segment AC. Okay, so we're doing midpoint formula how many times? How many times?
Why don't you do it twice?
Twice, right. 2 times because you're doing the 2 diagonals. There's only 2 diagonals, so 2 times. All right, so remember midpoint goes average the x's, divide by 2 to get your new x, average your y's, divide by 2 to get your new y. Okay, BD midpoint is going to be, let's see, BD is here. 3 plus 7 over 2. And 5 minus 1 over 2, or 5 plus -1. Same thing. Okay, what's that going to simplify to?
5, 2. Oh, sorry.
What is that going to be?
It's gonna be 5 comma 2.
Right, 5, 2. Okay, and then we're going to do the midpoint of the other diagonal. And again, that should come out to be the same because we know it's a parallelogram. It told us in the problem that it was a parallelogram. So it better turn out to be the same. If I said to you, is this a parallelogram, and I gave you 4 points, you could check the midpoints of the diagonals. And if they're the same, then it's yes. And if they're different, then it's no. Okay, so for segment AC, Sarah, can you give me the midpoint calculation for that one, AC? Sarah?
Yeah.
Can you give me the midpoint calculation for that one?
Midpoint x1. 3. Oh wait, no. 9 minus 3.
Here's the formula. You're adding x over 2, and then you're adding y's over 2.
Oh, it's plus. Okay. 3 plus 9.
Make sure you get x's together.
Oh, it's 1 plus 9. Okay, sorry.
1 plus 9 over 2.
Over 2.
And then what about the y?
And 3 plus 1 over 2.
Right. Now, again, also, you know that these are supposed to be the same value. So if you make a mistake in the calculations, or if you use the wrong formula, something's going to not seem right because you're not going to get the same answer, right? So 10 over 2 is 5. 4 over 2 is 2. We got the same answer. And that means that the diagonals do share a midpoint, which means that it is a parallelogram, which again, that's what we were supposed to be determining. Okay, so this is your midpoint here. Okay. So since BD and AC share a midpoint, so ABCD is a parallelogram. Okay, now, again, usually on a quiz, like on homework, I'm going to tell you to do it different ways because I want you to practice different options. And usually on a quiz, I'm going to tell you which way, like I'm going to say, do it this way. But if you have a choice between doing 4 slopes, 4 distances, two slopes and two distances. So again, that would be like what's circled in green there, or circled in orange here. Or two midpoints. What's the easiest?
2 midpoints.
Midpoints, right? So if you get to choose, two midpoints is definitely the easiest. Okay, but on the homework, you're going to see, let's go ahead and import homework here. Homework number 10.
Can we turn this into classwork?
Yes. So go ahead and submit your lesson 6-3 notes. Submit that to classwork number 3. You should have already submitted the first 2 pages to classwork number 2. And then this one is going to classwork number 3. Thanks for that reminder, Jake. I think that was Jake. Austin, you and Jake kind of sound alike to me. Okay, homework number 10, is that what I said it was? Is going to have all these coordinate geometry problems. So again, when you import that, please change that to say homework number 10, which is 6-3, day 2. Now, what I want you to notice is it is telling you, okay, so I'm giving you graphs on these so that you can draw the picture and, you know, kind of help you figure out like which are the opposite sides and which are the diagonals and whatever. I think it's helpful to have the picture there. Make sure that you simplify radicals. So like how we broke down root 8 into 2 root 2, make sure you simplify radicals. But highlight this for me right now. It's telling you to use slope formula. Okay, it's telling you on the second one to use distance formula. It's telling you on the third one to do distance and slope. And it's telling you in the fourth one to do midpoint. This is the same exact orders and notes we just did. So when you do slope formula, how many slopes should I be able to see? How many slopes do you have to calculate?
4.
4. 4 slopes. And you're doing that on the sides. Okay. For the next one, there should be distance formula 4 times on the sides, right? Distance and slope. Braden, how many distances, how many slopes?
2 distance and 2 slope.
Okay, and you have to do it on which sides?
Isn't it the opposite sides?
Okay, and if you do, so distance 2 times, slope 2 times. If, so STUV, let's say it's like this. If you do the slope of ST and VU and you get that they're parallel, what sides do you do the distance of?
SV and TU.
If you do slope here and get parallel, and you do distance here and get congruent, that doesn't prove that it's a parallelogram. Once you do 2 distances, 2 slopes, where do you do the 2 distances?
Isn't it on the same side?
The same pair of sides, okay? So it doesn't matter whether you pick ST and VU, or whether you pick SV and TU, but whenever you do distance and slope mixed together, you have to make sure it's on the same pair of sides. Okay, distance 2 times and slope 2 times on the same pair of sides. Because again, it could be an isosceles trapezoid if you get one pair parallel and the other pair congruent. Okay, make sure you pick one pair and do 2 slopes and 2 distances. You don't have to do 8. Okay, you just pick one pair of opposite sides. You might pick different ones than somebody else picks, but as long as you pick 2 sides that are opposite and you show they're parallel and congruent, then you're done. Okay, and then midpoint formula. Michael, how many times will you have to do midpoint?
2 times.
And what segments do you use when you do that? Like, are you using sides, or what are you using when you do the midpoint formula?
The 2 sides.
The 2 what?
Like the picture you just drew, or like the 2 sides. Like the 2 parallel sides.
Okay, when you do midpoint, you're not doing a midpoint here and here, and you're not doing a midpoint here and here. What do you think midpoint of? Midpoints of?
In the middle
It should be
of the,
right of the
yes.
what?
Trapezoid.
What are those things called?
Segments.
Yeah, but when they join non-consecutive sides, when you go across the shape like that, what's that thing called?
A bisector.
She needs to phone a friend who can help out. What's that called?
Yeah.
Diagonals.
Diagonals, right? Thanks, Lily. Okay, so when you do midpoint, you're just doing it twice, but make sure you're doing it on diagonals. If you do it on the sides, they better not be the same. So make sure you're doing on the diagonals. Okay, that's the first page, is doing those formulas. And then the second page is going to be some more stuff that is similar to what we did today. Okay, all right, we're finished for today.